Hello folks, Dave Mayo here for episode 2 of the Health, Happiness, and Performance Show. And we mentioned in our first episode we'd be focusing on how to live a healthy lifestyle. And obviously the Healthy Lifestyle program or Healthy Lifestyle show is taken. And my second choice, the Joe Rogan Experience, was also taken. Obviously a joke there. I hope to kind of illustrate to you how to live a healthy lifestyle. I'll do this by talking about things I do for myself and then a little bit of basic science. So today we're going to kind of use both to help you understand something known as circadian rhythms. Now, circadian rhythms are biological processes that typically take place over the course of the day. You are familiar with this. For example, we generally fall asleep at night and wake up in the morning. That's a circadian rhythm, but there are dozens, if not hundreds, of other processes that happen to us every day that follow a circadian rhythm. So what we have are these endogenous rhythms. These are rhythms generated within our individual cells that kind of give us an edge. For example, we wake up every single morning. This is an endogenous process, but it's regulated by behavioral patterns. So what do we mean by that? A behavioral pattern is something that you do and it follows either a daily cycle, it can follow a weekly cycle, monthly cycle, but our behavioral patterns and circadian patterns, they kind of work with one another. Our circadian rhythm drives our behavioral rhythm, and our behavioral rhythm drives our circadian rhythm. And I find many people kind of get this confused. They think that they're simply going to, stare at a sad lamp for 30 minutes every morning, put on blue blockers at night, and do time-restricted eating, and that's going to cover their circadian rhythms, which that is not even remotely true. And in today's show, we're going to discuss why that is, how circadian rhythms work at the cellular level, how these things that happen at the cellular level have an impact on our organs and tissues, as well as how our behavioral rhythms help our organs and tissues synchronize with one another. So let's just start at the very beginning, the very basic level on how do our cells tell time. So we have an internal clock that is essentially regulated by these two proteins, BMAL1 and clock. Now these two proteins essentially build up during the day. They end up binding to one another, and then they go into the nucleus of our cells and they turn on a suite of genes that regulate our circadian rhythms. And within these genes are clock-controlled genes. And these clock-controlled genes help function as a timer, similar to the sands in these hourglasses. For you young folk, this is an old way of telling time. It was something that we used in games back when I was a kid, but way back in the day, we actually used it kind of as a timer. Now you can just use your iPhone. But the way that these work is we turn them over like this, and the sand slowly goes in. Now, this is not an hourglass, this is a minute glass, but this same kind of system works within our cells. So when BMAL and clock go into the nucleus, they turn on the production of these genes, period and cryptochrome, and that kind of starts the clock. I guess whether it's starting or stopping the clock is all about perspective. And so you begin building up these period and cryptochrome proteins inside of our cell nucleus, right inside of the cytoplasm of our cell. And as these proteins build up, they eventually infiltrate the nucleus as BMAL1 and clock did, and they inhibit their own production. So what happens is now we have all this period and cryptochrome just floating. We're not producing anymore. And what happens is our cellular machinery begins to degrade period and cryptochrome. As you degrade period and cryptochrome, that removes the brake on BMAL1 and clock, and then we can start over again the next day. Now there are other clock-controlled genes such as reverb A as well, or reverb A and ROR-A, which help kind of fine-tune the clock within our cells. And it's important to point out that we have a master clock in our brain, an area called the suprachiasmatic nucleus, that's known as the master clock because it exerts some level of control over the other clocks, not total control. Our behavior is going to play a big role in that. But we also have these individual clocks in every one of our cells that help tell the time. Now we have this internal mechanism. it's still going. We have this internal mechanism that helps the clocks run on a specific time. So I have an endogenous rhythm. I'll make it up. People are not exactly on the 24-hour clock. Some people are a little less, some people are a little more. My endogenous rhythm is completely different from your endogenous rhythm. Everybody's is different. But the great part about this system is that we have a way of resetting the clock every single day, and that is via behavior, via light exposure, feeding times, increases in body temperature, as well as using these individual systems. For example, when you wake up in the morning and you get up and you start moving around, you're kind of turning on the muscle clock, so to speak. When you begin to eat, you're kind of turning on the gut clock. Liver clock, all these things are going to kind of turn on at different times of the day that are appropriate for their own function. So we have these cellular mechanisms, and we have the master clock exerting some level of control over the other clocks, but then we have these circadian endogenous rhythms creating behavioral rhythms. And so we wake up in the morning, we open our eyes, we get up, we move around, and we get up and do whatever it is we have to do. Some people immediately wake up and eat, some people move around and get a drink of water, some start their coffee, some take their shower. And then these behavioral rhythms are going to exert a wide level of control over these cells in our body. So within each kind of organ and tissue, we have hormones or signaling molecules that are created by these tissues that signal to the rest of the body and cells elsewhere, hey, we're starting, let's kind of coordinate with one another. So, for example, there are myokines, which are signaling molecules released from muscle. There are adipokines, which are signaling molecules released from fat tissue, and so on and so forth. There are gut signaling molecules, such as glucagon-like peptide 1 and other factors. Bile is likely a really important factor for helping our gut tell the time, and it kind of helps coordinate the liver, which produces bile, with the gallbladder, which stores it and releases it into the gut. So as you can see, you want all your organs to be on the same time, the proper time, so that everything can work well together. And so numerous things can kind of gum this up. For example, our metabolism is really important for our circadian rhythm. So things like blood sugar, blood triglycerides, and things of that nature. We should have blood ketones, as well as short chain fatty acids. These things rise and fall throughout different periods of the day, and that helps our whole body set the time. So what happens is, when we say like somebody who's obese, their adipocytes, their fat tissue is just constantly secreting molecules and inflammation that really screw up their circadian rhythms. Sedentary people, they're not going to have as strong of a signal emanating from their muscle and bone as people who get up and are physically active and are exercise. Physical activity and exercise are completely different. We're definitely going to talk about that. So what we have is this coordination, and we need, how do we get, what kind of signal can we use where we have different cells that speak different languages? What can we use to synchronize all of these different cells, organs, and tissues together so that they're on the same time? And as it turns out, we kind of have a pretty good idea of what that signal is, and that signal is body temperature. So when we get up, we wake up, generally speaking, a couple hours before we've woken up, our body, our core body temperature has been hit its bottom, and it begins to increase. And then we wake up, we get up, we move around, we're generating heat with our muscles. That increases temperature as well as this endogenous circadian rhythm. So see, we have this circadian rhythm, which is following this increase of temperature as we wake up. Then we're going to get up and walk around, we're going to generate more heat. Then we're going to eat, which generates more heat, and so on and so on. So yes, getting proper light exposure is important. Most people are not doing that right, especially if they're just staring at a sad lamp and putting on blue blockers. Yes, the feeding and fasting cycle is important because it does change metabolism, which is going to signal throughout the body the time of the day. It also increases body temperature. But if you are inactive, your body temperature curve is also going to be blunt. So whereas we have a physical activity generating heat like this day as a day-night cycle, people who are sedentary are going to have a much smaller curve. And with circadian rhythms, you want to think about this kind of like a radio, like a signal from a radio. The stronger the signal you get, the better rhythm you're going to see. You're going to be able to hear the highs and the lows of the song, so to speak. So with circadian rhythms, it's important that we not just stare at light at different times of the day and do time restricted eating. That is not sufficient to set a strong circadian rhythm. We need adequate physical activity. We need probably a diet, certainly a diet that is not providing too much energy in the form of calories every day. We do want some level of stress management and good sleep hygiene, because even though we generally fall asleep at night, our exposures, our environmental exposures to things such as stress can prevent us from falling asleep, and increasing your body temperature immediately before bed could also have the same effect. One of the important things of that body temperature curve is as our body temperature begins to decline, that helps promote sleep. And if you kind of screw up that signal, you can really cause problems. So there are different levels of importance for things that you need for circadian rhythms. Yes, the very simplest things to do are get your light exposure right and start time restricted eating. But that is not going to optimize your circadian rhythms whatsoever. You definitely need a nutrient dense diet, a proper exercise, getting regular physical activity, and things of that nature. So we'll cover that more in future blogs, and then we'll move on from there. Just to everything that I discuss, I really like to kind of bring back to these circadian rhythms and why they're important. And we're going to discuss different foods and why they're important for circadian rhythms. When we talk about diet, we're going to talk about how exercise influences that when we talk about exercise, and so on and so forth. So thank you very much for listening. If you have any questions, pop them down below, and I hope you enjoy your day.